Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Force and Laws of Motion. In the previous video, we understood what is force, balanced and unbalanced force, inertia, and Newton's first law of motion, which is related to inertia. In this video, we are going to learn about a quantity called momentum and how it can explain Newton's second law of motion. Now let's come to the moving body or motion. So whenever a body is moving, the quantity of movement or the motion is related to two aspects. One, its mass. Second, its velocity. So we have to consider both these for a moving body. So let's take an example how they are related. Here, suppose if I take two different balls, one is a cricket ball and other one is a tennis ball. What is the main difference between these two? We know that cricket ball is heavier than the tennis ball, which is soft and lighter. Now, if both of them, suppose cricket ball has got a weight of a mass m1 and whereas the tennis ball has mass of m2. But both are moving with the same velocity v. So the velocity is the same for both of them, but one is having mass m1 and it is m2. So you know that m1 of that cricket ball is more than the tennis ball, right? So now let's see when we are trying to stop it. We know that whenever we are trying to stop the moving body, we need to apply an unbalanced force. So which one you should apply more force to stop? Of course the cricket ball, right? So the cricket ball is heavier and tennis ball is lighter, both coming with the same velocity, but the force required to stop cricket ball is more than that of the tennis ball. So we know that here, which is a parameter different here, velocity is the same, but mass was different. So we could find that the force is directly proportional to mass. When mass increased, we needed more force to stop it. When mass decreased or lighter the tennis ball, we needed only less force. Now take a different scenario. We have two cricket balls, okay, both are cricket balls with the same mass. Mass is the same, but here both are coming with the different velocities. First one is coming with the velocity v1, just for understanding. Second is v2, but the first ball has more velocity. Now tell me, where should you apply more force in order to stop it? The one coming with a higher velocity or greater velocity needs more force to stop. So that means here mass is the same. So velocity is making the difference in the force applied. So we can say that force is directionally proportional to the velocity as well. So first we saw force is directly proportional to mass. More force is required. The same way we found force is related to velocity also. More force, more velocity is required. So if you combine these two, what will we get? F is proportional to m into v. This is the concept of linear momentum. So we found force is directly proportional to its mass and also to the velocity. The linear momentum of a body moving with a mass m and velocity v is defined as the product of mass and velocity. So momentum is nothing but what the mass and velocity. So we can see momentum is written as p. So momentum p is equal to mass into velocity. So multiplying mass and velocity of a moving body, we can find out the momentum. And here, since we are talking about the straight line, we are talking about linear momentum, or in your textbook simply momentum. So what is the symbol for momentum? P. And what is the formula for momentum? Mass into velocity. Now what is the SI unit? So mass, what is the SI unit? Kilogram. Velocity, what is the SI unit? Meter per second. So the unit of momentum is kilogram meter per second or kilogram meter s to the power of minus 1. That is, when we bring s from the denominator to the numerator, it becomes minus 1. So this is the unit of momentum. So momentum is nothing but the mass multiplied by velocity. We saw that Newton's first law was related to inertia. The same way, Newton's second law is related to momentum. So according to Newton's second law, the rate of change of momentum of a body is directly proportional to the applied unbalanced force. That means by applying an unbalanced force, we can change the momentum. But the rate of change is directly proportional to unbalanced force. So we know that whenever we are telling just a change of momentum means, suppose first momentum is a 10 kilogram meter per second, whereas second is a 12 kilogram meter per second, then what is the difference? 12 minus 10. Okay, that concept is very clear. But what does mean by rate of change of momentum? So whenever we apply the word rate, that means we are considering the time as a factor here. For example, suppose I am keeping 10 books on the table in 2 seconds, okay, whereas my friend is keeping 20 books on the table in 4 seconds. Ultimately, if you don't see the time, then we might think that, okay, she did more work than me, because I could keep only 10 books, she could keep 20 books. But if you consider time, I kept 10 books in 2 seconds, she kept 20 books in 4 seconds. So ultimately it is the same. So rate is the same for both of us, right? So whenever we are considering time in any of the parameters, then we call it as rate. Okay. So now let's see rate of change of momentum. For that, consider a body of mass m. Okay. It is moving with an initial velocity u. We know that we usually take u as the initial velocity. Then we are applying an unbalanced force, because only with unbalanced force we can change the uniform motion. So now from u, the velocity turns into v. So now the velocity is v because it was moving with u. We applied a force and we increased it to v or decreased it to v, we do not know. So u became v. So u is the initial velocity, v is the final velocity. So we know that momentum means what? Mass into velocity. So what is initial momentum? Initial momentum easy to find out. What is the mass initially? M. What is the velocity initially? U. So m into u, mu. Then what is the final momentum? Final momentum is again m into v, mv. Okay. So now what we have to see is change of momentum. Change of momentum is mu minus mv, right? Mu minus mv. Now what is a rate of change of momentum? That means we have to consider time also. So that becomes mv minus mu upon what? T. Time also consider. Now if I take this rate of change of momentum is directly proportional to mv minus mu by t. So m is a common factor, I am taking m out. So what will I get? V minus u upon t. But we have heard this somewhere. Change in velocity by time. What is it? That is called acceleration. So we can write rate of change of momentum means acceleration. Why? Because m into v minus u by t is acceleration into mass, or we can write ma. M into a. Rate of change of momentum is m into a. What did Newton's second law state? Rate of change of momentum of a body is directly proportional to the applied unbalanced force. So here F force is directly proportional to rate of change of momentum. Rate of change of momentum we found it is ma. So F is proportional to ma. Whenever we have to change a proportionality sign, we have to bring in a constant. Usually we take it as k, but sometimes it varies, but here we can take it as k. So if I want to change this proportionality sign into equals, I will add a constant k, ma, k into ma. So the unit of force is Newton. So how will you define 1 Newton of force? 1 Newton of force is defined as the force which can when act on a body of mass 1 kilogram can accelerate it to 1 meter per second square. So the force which can act on a body of mass m and change its acceleration 1 meter per second square, then that is called a what? 1 Newton. So 1 Newton will be k into 1 kilogram into 1 meter per second square. So we can take k as k is equal to 1. Constant k becomes 1 in this case if we are considering 1 Newton. We can rewrite this equation as F is equal to m into a. Force is equal to mass into acceleration. So that is the equation for second law of motion proposed by Newton. So through first law, we understood what causes the force, that is about inertia we learned, and unbalanced force, everything came into consideration. Whereas here we are calculating that force, that is F is equal to mass into acceleration, how much change in velocity happened into mass. So this is called a Newton's second law of motion, that is the rate of change of momentum, that is m into v minus u by t, that is ma, is directly proportional to applied unbalanced force F. So ultimately, if the constant is 1, we can say F is equal to ma. What is the SI unit of force? It is Newton. We learned momentum is mass into velocity. Is it a scalar quantity or vector quantity? It is a vector quantity because mass does not have direction, so it is a scalar quantity, whereas the velocity is a vector quantity because it has both magnitude as well as direction. So in this case, momentum also can be considered as a vector quantity. So it has a both direction and a magnitude. Now, since we told that rate of change of momentum, so momentum can be changed by adjusting the time, increasing the time or decreasing the time, we can change the momentum. We saw that force is directly proportional to rate of change of momentum according to Newton's second law. So, more the rate of change of momentum, more the impact of force in that particular situation. Less is the rate of change of momentum, that means it is happening slowly, then the impact of force also will be less. So this is applied in different daily life scenario. When we talk about that further, you will understand. The first example we are studying is a karate player when breaking a pile of slab or tiles. You know that it is one of their activities because they focus on the strength in their hand. So they keep a pile of slabs or tiles and they break it. But you can see that they try it several times and with a very fast and very quick blow or hit, they break it. Why? If the movement is slow, then what happens? Rate of change of momentum is less. So in order to make the momentum, that is the rate of change of momentum the highest, they make it so fast that since the rate of change of momentum is high, the impact of force also will be high, which will break the piles into pieces. When we gave less time, the impact of force was very high. So the opposite also we can apply, means we give more time to reduce the impact of force. For example, in the case of cricket, for a fielder, when she or he is taking the ball, for suppose it's a catch, when they are holding it, they are not simply holding it as such, because it is not a sudden movement. They will be bringing their hand, suppose they are taking like this, they bring it like this. That means they are moving their arm backwards. So if they simply stop it, what happens is this very high impact of the ball. Even though cricket ball is already heavy, it has a high velocity, it is coming. So just trying to stop will maybe fracture your arm. So you have to give time, so that what you are doing, you are reducing the momentum. So the rate of change of momentum is also slow, which will reduce the impact or the force acting on your hand, and that is safer for your hand or the fielder's hand. Another one is the athletes jumping. Either it is in a long jump or in a high jump. Usually high jump, they land on a cushion, or they will be in a pile of sand they will jump down to. They cannot jump onto a cement floor, which will lead to heavy injury for them. Why? Because here also when they are landing, we are giving more time so that they will be going inside the sand and slowly stopping. So give more time for changing the momentum. The rate of momentum is changing slowly and coming to zero. As a result, the force is also very less. So the impact is less, so they don't get much injury when they are falling onto sand. So, okay, this is about the Newton's second law of motion. If you understood the concept well, please share with all your friends. Give a like and comment if you have any suggestions or doubt. Thank you for watching Biology My Passion. Please subscribe to my channel.